Types of variation, inverse variation. Inverse variation is similar to inverse proportion discussed in tutorial 4.3. By definition, two quantities vary inversely when their product is always constant. Mathematically, we express an inverse variation as the following shown on screen. Or we obtain the following shown on screen. Where x and y are the quantities involved in the variation and k is the constant of proportionality. For example, the number of workers hired to do a job when multiplied by the time taken always provides a constant number, which indicates the size of the job to be done. As a special case of inverse variation, we can mention inverse proportion, which is an inverse variation between two quantities in two different instants, 1 and 2. In this case, we can write the following shown on screen. Or we obtain the following shown on screen. Obviously, the graph of an inverse variation is an uninterrupted hyperbola, while that of inverse proportion shows a finite number of points in the graph, the points whose coordinates represent the quantities involved in the proportion. Earlier we discussed both of these graphs in the example regarding the number of workers hired to do a job versus time taken, where the proportion and variation approach were used to express the data. Example 1. For identical pipes can fill a tank in 2 hours. A. Plot the graph of the hours needed to fill the tank depending on the number of pipes available. B. From the graph, find out how long it takes if we use 16 of the same pipes to fill the tank completely. Solution 1. A. This is an example of inverse variation, where the relationship between the number of pipes used to fill the tank versus the time taken is shown on screen. We express the time taken to fill the tank by x, and the number of pipes by y. Hence, from the clues, we can calculate the constant k first, as the following shown on screen. Therefore, the formula that expresses this inverse variation is shown in the following on screen. Now, let's plot the graph by taking a number of values as shown in the table in the following shown on screen. B. From the graph and table, it is clear that if there are 16 pipes available, they can fill the tank in 0.5 hours. Therefore, the more pipes that are open, the shorter the time needed to fill the tank. Another situation relevant to inverse variation is when we have to divide an amount into more than 2 shares, where the criterion is determined by the inverse relationship between the quantities involved in the variation. In these situations, we express the relationship as the following shown on screen. This is because when we consider each quantity on the left to the corresponding quantity on the right separately, we obtain the following relations shown on screen. Let's consider an example to clarify this point. Example 2. $420 are divided among 3 siblings aged 6, 8, and 12 respectively, inversely proportional to their ages. Find the amount each sibling receives. Solution 2. First, let's calculate the constant k of proportionality. If we express the siblings as A, B, and C, we obtain the following shown on screen. In addition, we have the following shown on screen. Therefore, we can write the following shown on screen. Hence, sibling A, who is 6 years old, receives the following figure shown on screen. Sibling B, who is 10 years old, receives the following figure shown on screen. And sibling C, who is 12 years old, receives the following figure shown on screen. That is all for lesson 4.5.4. To continue this tutorial, please watch 4.5.5, Types of Variation, Joint Variation. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.